Session 7.1, Learning about the word food service. For these sessions, we're going to talk about the definition of the populations, samples, parameter, and the statistic. Also, we're going to talk about what is the meaning of the bias in survey. And we're going to introduce the simple random sample. First, let's look at the populations and sample. Population is a group of objects or people we wish to study. Usually, the group is really large for the populations. For example, the citizens of United States is a large group of the people, right? A sample is a collection of objects or people taken from the population of inches. So look at this example. I want to find the mean weight of 10 years old girl in United States. Since my target is going to be all the 10 years old girls in United States. So that will be my target population. So this is going to be the 10 years old girl in United States. And then you know that there's no way you could find out all the data from the 10 years old girl in the United States because the population is really large. So what we're going to do, we're going to draw the sample from here. Okay, and then we take it out. And then we only find the mean weight of the 10 years old girls from here. So this is going to be the sample. So think about it. The population is going to be a group of the objects or people we wish to study. And then sample, this is talking about you taken from the populations. Parameters and statistics. A parameter is a number that describes an n-type population. Statistic is a number that describes a sample. Look at this picture. This is the population. Use our example. If we want to find the mean weight of 10 years old girls in the United States, then if we find the population mean, that's called the parameter. The parameter is a number who describes about the population. For example, you can find the population mean, you can find population standard deviation or population proportion. Okay? And then for the sample, sample is taken from the population. If we use the sample to find the mean weight of the 10 years old girls, this is called sample mean. And we use the statistic to describe the sample mean. So statistic is a number that's talking about the mean in here. Okay, you can have sample standard deviation or sample proportion. So that would be the statistic. Example, data is gathered on the height of all NBA basketball players. The mean of the data is calculated. So think about it. For this example, which one is going to be your population? What is your parameter? Population is talking about all the NBA basketball players. Right? This is what we target. And what's the parameter? Parameter is the number who describes the population. So in this example, we're talking about the mean. So that will be the mean height of the all NBA basketball players. Another example, try to do it by yourself. What is the sample? What is the statistic? A researcher is interested in studying the height of American women. So it takes a random sample of 1,500 American women, finds the mean height of the sample is 63.6 inch. So first, this is talking about the sample. So sample is 1,500 American women. And what is a statistic? Statistic is a number who describes the sample, right? So it's talking about sample mean of 63.6 inch. Okay, how about this one? Try this one. In January 2015, the Pew Research Center published a report stating that 37% of Americans believe that genetically modified foods were safe to eat. This was based on the survey of 2002 American adults. Identify the population and sample. What is the parameter of inches? What is a statistic? So first, think about it. What is the population? The population is talking about all Americans adults. So what is your sample? So this was based on a survey of 2002 American adults. And what is the parameter of inches? So this is talking about percentage of all American adults who believe that GMOs are safe to eat. It's all American, okay? Because the parameter who describe about the populations. So it has to be all American adults. And how about the statistic? Statistic is talking about like the sample, right? So we will have 37%, the percentage of the sample who felt this way. Statistic versus parameter. Statistics are knowable. Anytime we collect data, we can find the value of a statistic. Because statistic is described about the sample, so we could collect the data from the sample. So every time you should be able to find the statistic. Parameters are typically unknown. They can be estimated with the statistic, but this estimate will involve some degree of uncertainty. So think about it. Parameter is describe the population. Just like our example, we want to find the mean weight of 10 years old girl in United States. Is it possible that I could find the population mean weight of 10 years old girl in United States? No way, right? Because the population is really large. We have a hard time, or it may be too expensive to collect the data for the population mean. So that's why I say are typically unknown. So usually we'll be using the statistic to estimate the parameter. Of course, the estimate, it may not be exactly equal to the parameter. Example, consider these two sentences from the New York Times, November 5th, 2017. In election day exit polls, 81% of those who describe themselves as conservatives say they had voted for Donald Trump. Winston Churchill painted more than 500 pictures in his lifetime. So A, is the number 81% a statistic or a parameter? So if you want to know this 81% is statistic or a parameter, you have to think about it. This is going to be your population or this is going to be your sample. That will be statistic because the number 81% who describe the sample of people. B, is the number 500 a statistic or a parameter? So think about it. Will you guys consider his collection of the paintings will be population or the sample? That would be the population, right? So that will be a parameter because it describes a population, which is the collection of all of Churchill's paintings. Okay, notation. I need you guys remember all this notation. This is really important for these two chapters. So when you guys see the X bar, this is represent the sample mean. And then the S here, that will be sample standard deviation. S squared, that will be sample variance. And then the P hat, this is a sample proportion, okay, sample proportion. This is the population mean, population standard deviation, population variance, that will be the sigma square, okay? And this is a population proportion. We use the P as a population proportion. Make sure you guys remember all this notation. I will ask you guys in the midterm too. Bias. A survey method is biased if it has a tendency to produce an untrue value. 3 types. First, measurement bias. Second one, sampling bias. Number 3, use of an estimator that is biased. So we're going to talk about this one by one. Measuring bias results from asking questions that do not produce a true answer. Occurs when measurements tend to record values larger or smaller than the true value. For example, asking people, how much do you weigh? It is likely that people will report a number less than their actual weight, resulting in an estimate that tends to be too small. It's really common, right? When you ask me, hey, how much do you weigh? I will tell you guys I may only have 100 pounds, right? Because I don't want to let you guys know I'm that heavy or I'm fat, okay? So this is called the measurement bias. So if you guys collecting the data, you want to find out the people's weight or the height, it's better you could just do the measurement by yourself, okay? You may want to put the weight here and ask the girls, okay, close your eyes and step on it. And then record the weight of the girls by yourself. Measurement bias can occur in a variety of situations, including self-reporting of personal data, the use of confusing wording in a survey questions. Number 3, order of questions. Survey question is unintentionally loaded by such factors as the order of the items being considered. Look at this example. This is the real survey question. Would you say that traffic contributes more or less to air pollution than industry? So we are comparing about the traffic and the industry. And then second one, I will say, would you say that industry contributes more or less to air pollution than traffic? So if you guys look at number 1 and number 2, this is exactly the same questions. Okay, exactly the same questions. But if we put it on the survey, 45% is going to be banned on traffic, 27% is going to be banned on industry. Second one, 24% banned on traffic, and then 57% banned on industry. It is because the order of the questions. Most of the time, when the people look at the traffic first, they're gonna ban on the traffic. The second questions, when the people look at the industry, so they're gonna ban on the industry more. So instead of putting the order of the questions, you may separate 2 parts of the questions. One is specific for traffic, one is specific for industry. Sampling bias occurs when using a sample that is not representative of the populations. For example, internet posts. People who answer this post tend to be those who have strong feelings about the results and are not necessarily representative of the populations. The internet post, sometimes when you guys open some website, they could pop out the screen here, say do the survey. Like some people with it, like the topic, they may feel interesting, then they could click on it. Like some people may say, hey, this is none of my business, they may just go away. So we call this as the sampling bias. Simple random sample. A random sample is one in which every member of the population is equally likely to be chosen for the sample. So if we want to apply the simple random sampling, we have to make sure everyone have the equal chance being picked. And simple random sample, always when you draw the subjects at random from the population without replacement. So after you pick it out, you can put it back and draw it again. Okay? statisticians have developed methods for producing random samples that can be used to estimate characteristics of populations. Remember we say we have the sample is taken from the population. After we finding the sample mean can be estimated the population mean. So we try to, using the simple random sample, find out the statistic and to estimate the parameter. But in reality, true random sample is difficult to achieve because we can't really make sure everyone have an equal chance to being picked. That's it.